Hello, welcome back to our NLP series. In the last episode, we explored the first step of text preprocessing, tokenization. You saw how raw text gets split into smaller, meaningful pieces called tokens. Today, we're moving to the next stage, cleaning up those tokens so they're more useful for us. Specifically, we'll look at three things: stopwords, stemming, and lemmatization. If you're new here, I'm RC Rajendran, a data scientist with over 6 years of experience. I started from a non-technical background myself, so I know the struggle of trying to learn AI basics. That's why I'm here, to make these concepts fun, example-oriented, and super easy to understand. So hit that subscribe button and let's jump right in. Let's start with the stopwords. Stopwords are common words in English like is, the, and, was, and on. They appear so frequently that they don't add much meaning in many NLP tasks. For example, Harry was walking quickly. This is an example sentence. So here our tokens are Harry was walking quickly. So we have 4 tokens. Here, was doesn't really carry information, although we know that Harry was walking in the past tense. But if you remove it, we still understand the core meaning: Harry walking quickly. That's all the machine needs. That's the purpose of removing stopwords, to focus on the more important words. Let's look at a quick script, for example. So we use the same NLP library we used last time, NLTK, and we import stopwords from it. So this specific line of code tells the script to make use of the English language to understand and remove the stopwords from the English language specifically. So if you have a couple of words in these square brackets and assign to a variable, that is called as a list. So now we are going to filter only the words that are not stopwords. So that's what this specific line of code does. And when you print it, the was disappears. So you only get 3 tokens, 3 words. But here's the catch. We don't always remove stopwords. For example, in sentiment analysis, the word not is very important. Removing it changes from not good to just good. So use stopword removal very carefully. Understand the use case and problem statement carefully before implementing it. Next, we have the concept called stemming. Stemming, although it kind of sounds like you're gonna, cut out the stems of flowers in your garden, but it's not that. So stemming reduces words to their root by essentially chopping off endings. So the words running, runs, runner essentially is chopped off into its root word run. This way, different variations of the same word are treated as one. But it's not perfect. Stemming is fast and mechanical. It doesn't always produce real words. So we'll take another look at the example. Now we are importing part-3, which is the module that takes care of stemming the words or sentences that we give it. Now we are stemming the words running, runner, and better. So now we expect better to be reduced to good, right? Because good is the root word for better. But no. Better remains the better, and the rest of the words running and runner becomes run as expected. It doesn't know the correct root for the word better, so it leaves it as better. That's the weakness of stemming. It's a quick shortcut, but it's not context aware. So to fix that, we have another concept called lemmatization. I know, all complex jargons, but it will all make sense in a while. Lemmatization is a smarter variant of stemming. It uses dictionaries and context to return proper base words called lemmas. So, for example, the word running becomes run and better becomes good when used in the context of adjective, right? So, while stemming just chops, without any meaning, lemmatization understands the meaning of the word and then it chops the word and then returns its root word. Let's take a quick demo. So from the same NLTK NLP library, we are importing WordNet Lemmatizer, which is the module that we would use in order to lemmatize the words into its root form. So we are downloading the WordNet resource, which has the WordNet lematizer function, and we are initializing it. So now when we lematize the word running and assign POS equals V. So what does this mean? POS is parts of speech. So if it is a verb, it's an adverb, or it's an adjective, and so on. So V here means verb. So the lemmatized function understands that running is a verb and then it has to be reduced to its root form. So here it gets reduced to run. Now the lemmatized function went better, and then we are tagging it with POS equals A as in adjective. So better becomes good. Now you see the difference. Lemmatization correctly maps better to good when we specify it as an adjective. This is much closer to how humans use and understand language. So far, we have tokenization from the last episode, which splits text, stopwords removing common, less important words, stemming, chopping words into roots, and lemmatization, its context-aware root words. Together, these steps clean our text and prepare it for more advanced NLP techniques. So let's recap what we've learned today. Stopwords are common words like is, the, and. Removing them reduces noise. Stemming chops words down into their root form, but it can be crude. That is, it is not meaning aware. Lemmatization is smarter, returning proper dictionary-based forms. It understands the usage and understands the meaning and returns the correct root form. These techniques help us clean text and make our text more meaningful, or the tokens are made more meaningful for the machines to understand. In the next episode, we'll transform text into numbers using bag of words and TF-IDF, two key methods for feature extraction in NLP. So don't forget to like, subscribe, and comment below if you tried the code examples today. I'll see you in the next episode.